Hi, I'm AnaCross, Associate Product Manager for Air Handling Units at Delta Group. I've been working within the company for over 12 years now, and I've recently become an accredited professional for the Reset standard. I would like to thank CIBSE and the organising committee of this year's technical symposium for this great opportunity to be presenting my paper to you today. I hope you enjoy it. Eco-designing an NRVU BVU for enhanced indoor air quality. So today's presentation starts with three key questions that drive the line of thought of its content, followed by a timeline for Eco-Design Directive and ISO 16890. The first question is left open to discussion, but I suspect that all building industry professionals and ventilation specialists, as well as FM managers, know the answer to it. We will then move on to finding the answer to the second question by using digital models of an NRVU BVU, commonly referred to as a commercial heat recovery unit, and finalising with the real game changer, a 5-step process of choosing an ISO 16890 filter and thus designing for good indoor air quality. So these are the three main questions. Is the built environment delivering good quality air to its users? Can a balance between energy efficiency and indoor air quality be found? How do we select an ISO 16890 filter for enhanced indoor air quality? Air filters, in this case for dry pollutants, significantly influence the indoor air quality of the built environment by reducing people's exposure to harmful levels of particulate matter. In the process of design the system, consideration needs to be given to the quality of the outdoor air around the building or proposed location for the building. It is via the cascading implementation of the new global standard ISO 16890 that the design team now has the means to confidently write a specification requisition for air filters in terms of dry pollutants for the supply of good quality air to the users of a project building. Eco-designing an NRVU BVU. The design of a heat recovery unit is directly connected to two main eco-design requirements: thermal energy recovery efficiency and specific fan power. Combined, the two requirements impact on four distinct areas: energy efficiency, unit footprint and cost, and indoor air quality. In order to compare current requirements against eco-designing an energy recovery unit in accordance to European directives and its progressive implementation, a software tool was used to generate 3 heat recovery unit models under identical general conditions. More frequently than expected, the selection of fine filtration is compromised in favour of lower filter grades in order to achieve compliance for specific fan power. The process of selecting filters cycles and repeats itself until the perfect balance between selecting finer filtration for enhanced indoor air quality and energy efficiency is found. ISO 16890 Keywords and Definitions. The real benefit of ISO 16890 is that it takes the design team on a journey. By splitting dry pollutants as particulate matter into 4 main filter groups against the reference particles' optical sizes and by defining minimum efficiency values for each group, ISO 16890 enables the design team to confidently choose the correct filter for each application. This process is further detailed by the definition of new ODA and subcategories. meaning that the design team is now able to identify the outdoor air category based on pollution levels against the World Health Organization 2005 guidelines for particulate matter present in the local environment, and define the supply air quality category for the project building. By combining these criteria, the design team has now found the minimum filtration efficiency recommended against the quality of air outdoors, ODA, and the target supply air quality, SUP, to be delivered into the project building. So if we were to consider a project building to be located in an ODA3 environment, like urban clusters such as Manchester, Birmingham or London, and for which a sub-2 category is expected to be delivered to its users, then the project team will be able to clearly identify that the filter required would be an EPM1 80%, and that will be the minimum recommended efficiency level for the filtration in the HVAC equipment. This table is literally just a generic summary of the usage of the project buildings against the target subcategories, with the sub-1 category being left for applications with very high hygienic demands. Designing for good indoor air quality. Presently, environmental data from local or national monitoring networks is readily available, enabling a more realistic understanding of the category of outdoor air quality, or ODA. Here we've got a snapshot of the PM2.5 and PM10 maps for the UK, and we can easily see where the pollution hotspots are. So the design teams can therefore be better prepared to identify the minimum filtration efficiency required against a specific ISO 16890 filter group in order to achieve the designed supply air quality category or subcategory. The specification requisition of a filter for a project in London is therefore different from one for a project in the Yorkshire Dales. But how exactly do we get to the minimum filtration efficiency required? A simplistic 5-step process is now proposed. The first step is to match project needs to the local environment, understand the location of the project building, followed by making use of the outdoor air quality data that is publicly available. Step 2 results in finding the ODA category. The third step is to define the relevant subcategory for the project. What quality of air is the project building delivering to its users? Is it a sub-3 or a sub-2? In step 4, we do some basic maths to find the reduction in pollution required based on the ODA real measurements. This is data from the monitoring networks. And finally, in step 5, we will be able to identify the minimum recommended filter efficiencies. This is an example of calculating the minimum recommended filter efficiency against an ODA3 outdoor air with the aim to achieve a supply air quality category, a sub-2. The design team is recommended to make use of an EPM10 filter with minimum efficiency of 80%, an EPM 2.5 filter with minimum efficiency of 85%. This doesn't mean that there's a need for a 2-stage filtration, but it is clearly shows the crying need for finer filtration. And the final conclusions are that the balance between energy efficiency and indoor air quality can indeed be found, as long as all industry specialists accept that filter selection needs to be the starting point of the design process, instead of being an afterthought. Unfortunately today, the outdoor air is polluted and fresh air design is a thing of the past, so we really must think of filter selection in terms of ODA and subcategories. How efficient must a filter be to offset enough dry pollutants that will satisfy a supply air quality category? The new ISO 16890 filter classification for general ventilation tells us the whole story. If I refer to an EPM 2.5 filter at 65%, I know that such media is 65% at filtering PM 2.5 particles out of the airstream. This might be sufficient to satisfy a sub-3 category. Or even if I refer to an EPM 175%, I understand that the media will be filtering dry pollutants so small that can be absorbed by the bloodstream, and these are suspended particles smaller or up to 1 micron in size, and the media will be working at an efficiency level of 75%. So we've understood then how to correlate ODA categories with project building application and its desired subcategories by implementing a simplistic 5-step process. And I personally hope that today's presentation will help promote continuous delivery of healthier indoor air quality in energy efficient buildings for all its users and throughout its entire lifetime. Filtration is not just to protect the mechanical equipment from bumblebees and dry leaves, it is to enhance the air quality of the air we breathe indoors. Thank you for staying with me throughout this presentation. I hope you found the content of interest. Please send over your comments or your questions, and I look forward to speaking to you. Thank you.